Before the Big Bang, was there another cosmos? Why is the antimatter that should exist missing? What invisible forces move entire galaxies without us being able to see them? This audiobook accompanies you for 2 hours on a serene journey through the greatest mysteries of space, where each answer opens new questions. Scientists have dedicated their lives to unraveling these enigmas, and despite their efforts, many of them remain as perplexing as on the first day. What about the possibility of parallel universes? Bubbles of reality that coexist with ours but that we have never been able to explore? And what about dark matter, that invisible substance that seems to make up most of the universe but still refuses to reveal itself to us? Moreover, did you know that there are theories suggesting that the universe might have gone through cycles of expansion and contraction, a phenomenon known as the Big Bounce? Imagine the idea that the Big Bang was not the beginning, but just the last of many beginnings. What does that mean for our understanding of existence? And in the realm of the subatomic, supersymmetric particles present themselves as possible pieces of the puzzle that could reveal the hidden structure of the universe. However, so far their existence remains a mystery. What secrets could unfold before us if we ever managed to detect them? As we gaze at the starry sky, it is inevitable to wonder, what do we still have left to discover? The expansion of the universe, for example, is not a uniform phenomenon. There are indications that it might be happening unevenly in different directions. What implications would this have for our understanding of the cosmos? Each of these enigmas not only invites us to reflect on the universe but also on our place within it. The pursuit of knowledge is an endless adventure, and every answer we find generates new questions. Are we really alone in this vast space, or are there forms of life that we have yet to detect? As we continue exploring, we realize that each mystery solved can open the door to even deeper ones. Human curiosity knows no bounds, and our quest to understand the universe takes us to unexpected places. So as we embark on this journey of discovery, let us keep our minds open and ready to embrace the unknown. Who knows what mysteries the future holds for us? The adventure is just beginning. Can a universe be the result of an endless cycle of expansion and contraction? The idea of the Big Bounce, a concept suggesting that before the Big Bang there may have existed another universe that collapsed, invites us to explore the cyclical nature of the cosmos. This theory raises fascinating questions. Are we really living in the last chapter of an infinite cycle? Or perhaps are we the first chapter of a new beginning? Imagine a universe that expands and contracts, where each Big Bang is followed by a big crunch, a total collapse that leads to the creation of a new universe. This cycle could have occurred countless times, giving us a different perspective on the history of the cosmos. But how did we arrive at this conclusion? Physicists have analyzed the conditions that existed at the moment of the Big Bang and found that certain patterns might indicate that we are not alone in this cycle. The expansion of the universe as we know it began about 13 billion years ago. But what was there before that? The Big Bounce theory suggests that before our existence there was another universe that experienced its own life cycle. This previous universe may have been very different from ours, perhaps filled with physical properties and dimensions that we cannot even imagine. What kind of life could have existed in that universe? And what happened to it? The theories about the Big Bounce are supported by simulations and mathematical models that attempt to explain how a universe could collapse and then be reborn. However, these ideas are still the subject of debate among scientists. The lack of concrete evidence has led many to question the viability of this theory, so why do we continue to explore this concept? Perhaps because the Big Bounce provides us with a narrative that connects us to something greater, a story that repeats throughout eternity. However, not all scientists agree with the idea of the Big Bounce. Some argue that the universe has a definitive beginning and end. For them, the Big Bang was a singular and unique event, a moment when everything we know began to exist. But if the universe expands indefinitely, what happens when it reaches its limit? Does it stop, or could it in some way collapse again? The Big Bounce models also lead us to consider the possibility that our current universe is just a small fragment of a much broader reality. What if multiple universes exist, each with its own rules and characteristics? The idea of a multiverse intertwines with the Big Bounce theory, suggesting that each collapse could give rise to a new universe, each with its own physical laws. As we delve into these theories, we face existential questions. What does it mean for us as human beings to know that we might be part of an endless cycle of universes? Perhaps it reminds us that our existence is fleeting, yet also extraordinary. Each life, each experience could be a spark in an endless chain of creation and destruction. Moreover, the Big Bounce invites us to reflect on time. If time is cyclical, how does it change our perception of life and death? What if each ending is just a new beginning, a transition to a different state of existence? This could be a comfort for those seeking answers about what happens after death. The Big Bounce theory also raises the intriguing possibility that, in a cyclical universe, the laws of physics could change with each new cycle. This raises countless questions about the nature of reality. Could we at some point experience a universe where gravity works differently, or where time does not behave as we know it? The mysteries of the Big Bounce remain unresolved, and each new investigation brings us one step closer to understanding our place in the cosmos. Meanwhile, we are left with the curiosity and wonder of what it means to be here, in this moment, in this universe. The quest for answers drives us forward and reminds us that although our knowledge is limited, exploration is infinite. In conclusion, the enigma of the Big Bounce offers us a window into the possibility that our existence is just a chapter in a much larger and deeper narrative. The idea that the universe may have lived multiple lives raises questions about our own nature and our connection to the cosmos. So, as we continue to explore these mysteries, let us remember that each discovery is an invitation to look toward the stars and ask ourselves, what lies beyond what we know? If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. In the vast universe, one of the most intriguing mysteries is the missing antimatter paradox. Have you ever wondered why we are surrounded by matter and not antimatter? According to Big Bang theories, an equal amount of both should have been created, but the reality is very different. Matter, which makes up everything we see around us, seems to have won this cosmic battle, while antimatter, its opposite, appears to have vanished without a trace. What could have happened in the dawn of the universe for this to occur? Imagine a moment when everything we know, from stars to planets, was part of a monumental explosion. In that fraction of a second, particles of matter and antimatter were generated. However, for reasons we still do not fully understand, matter prevailed. But where has all that antimatter gone? Some scientists theorize that it might exist in regions of the universe that we have not yet explored. Or perhaps it was annihilated in collisions with matter in a process that occurred almost instantaneously. But that does not fully explain its absence. Antimatter is fascinating because its properties are almost identical to those of matter, but with an opposite charge. For example, if a matter particle is an electron, the corresponding antimatter would be a positron. When both meet, they annihilate each other in an explosion of pure energy. According to Einstein's famous equation, E equals mc squared, so why don't we see more antimatter in our universe? The search for answers leads us to consider various theories. One possible explanation is CP asymmetry, which refers to how matter and antimatter behave differently in certain interactions. This asymmetry could have allowed matter to become dominant, but so far, evidence is limited. Physicists are searching for evidence in particle colliders, where they recreate conditions similar to those of the Big Bang, trying to understand why matter had an advantage. But do we really find answers in those experiments? Another theory suggests that antimatter could be hidden in forms we cannot observe. For instance, some astrophysicists have proposed that it might exist in very distant regions of the universe, in far-off galaxies where matter and antimatter could coexist. However, that leads us to the question: how can we detect something we cannot see? The answer might lie in the radiation emitted by antimatter when it encounters matter, but the results have been elusive. The possibility of mirror universes, where antimatter is the norm, has also captured the imagination of many scientists. In this scenario, not only would our universe exist, but others where the rules are completely different. Could it be that these universes are so similar to ours, but with an inverse composition? The idea of parallel universes is fascinating and could offer clues about the lack of antimatter. As technology advances, new methods for investigating antimatter are emerging. Antihydrogens created in laboratories are being studied to understand their properties. If they behave differently from hydrogen atoms, it could be a crucial clue to solving the paradox. But where would that discovery lead us? Perhaps to a new understanding of the universe and the laws that govern it. Moreover, antimatter is not just an enigma from a theoretical standpoint, it also has practical applications. In medicine, it is used in positron emission tomography, a technique that allows visualization of metabolic processes in the human body. This demonstrates that despite its rarity, antimatter has an impact on our daily lives, even if we do not see it. The search for antimatter is also a search for universal identity. What are we really if all the matter we know is just a small part of a larger puzzle? The existence of antimatter could change our understanding of the history of the universe and offer us a new chapter in the cosmic narrative. But in the meantime, we continue to wonder, what secrets does antimatter hold, and why is its absence so significant? Advances in particle physics and cosmology continue. As we explore further, we find more questions than answers. The missing antimatter paradox is a reminder of how little we truly know about our cosmos. Each discovery can open new doors, and each answer can lead us to new questions. In this journey, human curiosity remains our best tool. In conclusion, the missing antimatter paradox is not just a mystery, but also an invitation to explore the unknown. It challenges us to look beyond the obvious and question what we think we know, as we continue to seek answers. Antimatter inspires us to keep exploring the far reaches of the universe and discover what other secrets await us. In the vast and mysterious cosmos, the search for antimatter is just one of the many adventures that lie ahead. What are primordial black holes, and why might they be the key to understanding some of the strangest phenomena in the universe? Since the beginning of cosmic creation, when everything we know began to expand from an infinitely small point, fascinating questions have arisen. Primordial black holes are objects that may have formed during that initial period, long before stars began to shine. But how is it possible for black holes to exist before stars did? To understand this, we must remember that the primitive universe was a very different place from what we know today. It was filled with extreme energy, density, and temperature. In those early moments, fluctuations in the density of space could have led to the formation of black holes even before stars formed. But what does this mean for us? Imagine a universe where these primordial black holes not only existed but also influenced the evolution of the matter and energy around us. Black holes are known for their ability to attract matter towards them with such intense gravitational force that nothing can escape, not even light. However, primordial black holes are an additional mystery, as they could have been much smaller than the black holes we know today. Some scientists believe that these objects could have had masses equivalent to those of asteroids or even less, but what happened to them? Why don't we see them in the current universe? An intriguing possibility is that many of these primordial black holes have disappeared or merged with others. However, some suggest that they could be hidden in the darkness of space, acting as a kind of dark matter that we cannot see directly. Could they be responsible for some of the gravitational effects we observe in distant galaxies? This raises an even deeper question. If these primordial black holes exist, what role did they play in the formation of the structures of the universe? the search for primordial black holes has challenged scientists to think differently about the nature of the cosmos. By studying gravitational waves, physicists have begun to gather clues that could suggest the existence of these objects. But how can we be sure that they are not just theories? The answer may lie in the way we observe the universe. Scientists are using advanced technologies to detect signals that could indicate the presence of black holes in unexpected places. A fascinating aspect of primordial black holes is how they might relate to dark energy. This mysterious force that seems to be accelerating the expansion of the universe could have unexpected connections with these black holes. Could it be that these black holes are part of the mechanism driving cosmic expansion? The implications of such connections are profound, as they could change our understanding of how the universe behaves. Moreover, the existence of primordial black holes could also resolve some paradoxes in cosmology. For example, if we consider the amount of matter and energy in the universe, the presence of these black holes could help explain why we observe so much mass in certain regions of space. Is it possible that these black holes are a form of matter we have not been able to detect until now? However, the idea of primordial black holes is not without controversy. Some scientists argue that their existence is unlikely, while others believe they are an essential part of the universe's history. What do you think? Science advances through debate and research, and the study of these primordial black holes is just one of many areas that promise to unveil the secrets of the cosmos. The fascination with primordial black holes is not limited to their existence. It is also about what they represent. These objects are a reminder that the universe is a place full of surprises and mysteries. Each discovery about black holes brings us a little closer to understanding the very nature of the cosmos and our place within it. As we continue to explore the universe, each new theory and each new finding about primordial black holes drives us to ask more questions. What other secrets does the universe hold? Could there be more surprises waiting to be discovered in the vast expanses of space? Human curiosity is insatiable, and every answer we find only generates more questions. So the next time you look up at the starry sky, think about primordial black holes. These mysterious objects could hold keys that help us unravel the past of the universe and its ongoing journey into the unknown. In our quest for knowledge, we must never forget that every question is an open door to new possibilities. What will we discover next? The search for a theory that unifies gravity with quantum mechanics is one of the most intriguing challenges facing modern physics. Why, despite our advances, have we not achieved a definitive answer? Gravity, which governs the movement of planets and galaxies, behaves in a completely different way than the subatomic particles defined by quantum mechanics. But what if these two forces could coexist in a single theory? Imagine a world where the forces of nature are described by a single equation. It would be like finding the holy grail of physics, uniting the macrocosm of the universe with the microcosm of particles. But what prevents us from achieving this? The answer lies in the inherent conflicts of the laws that govern each of these worlds. Gravity is a continuous and smooth force, while quantum mechanics is full of surprises and probabilities. How can we reconcile something as deterministic as gravity with the inherently random nature of subatomic particles? One of the most intriguing concepts that arises from this search is the idea of quantum gravity. But what exactly is it? In simple terms, it is a theory that attempts to describe gravity according to the rules of quantum mechanics. However, so far, all proposed theories have had to face problems and limitations. Why is it so difficult to integrate these two pillars of physics? The answer may lie in the complexity of the very nature of space and time. General relativity, which describes gravity, tells us that space and time are intertwined in a quantum fabric. But what happens when we try to apply quantum principles to this structure? Paradoxes arise in which space and time can behave strangely, even at a fundamental level. Imagine that at the heart of a black hole, the laws of physics as we know them could break down completely. What does this mean for our understanding of the universe? Some theories, such as string theory, suggest that particles are not points but rather vibrating strings in a multidimensional space. But how can we imagine additional dimensions that we cannot see? These dimensions could be the key to connecting gravity with quantum mechanics. However, experimental evidence remains elusive, leaving scientists in a state of uncertainty. Could there be ways to detect these hidden dimensions in the future? On the other hand, the search for a theory of quantum gravity has also led to the exploration of concepts like emergent gravity. This idea posits that gravity is not a fundamental force but a phenomenon that arises from interactions at a quantum level. If this is true, what other forces might be emergent in our universe? It could be that gravity, as we understand it, is nothing more than an illusion. Another fascinating aspect is the dilemma of cosmic entropy. How is it possible for the universe to transition from a state of high order to a chaotic one so quickly? As the universe expands, entropy should increase, but what about regions of space where entropy seems not to follow this pattern? Understanding entropy could be crucial for uniting gravity with quantum mechanics. However, each attempt to do so has led to more questions than answers. The information paradox also plays a fundamental role in this dilemma. What happens to the information that falls into a black hole? According to quantum mechanics, information cannot be destroyed, but relativity suggests it could be lost forever. What does this mean for the nature of reality? If information is lost, could it be that we are living in a universe where the rules of logic break down? Current theories such as loop quantum gravity attempt to address some of these issues, but can they really offer a definitive solution? Each theory seems to have its own limitations and challenges. The scientific community continues to debate which path is the right one, but the dilemma persists. Are we closer to an answer, or are we merely beginning to scratch the surface of a much deeper mystery? Time as we know it also becomes a topic of debate. Within the framework of quantum gravity, is time an illusion? Some theories suggest it could be an emergent construct, radically changing our understanding of the universe. If time is not absolute, how would this affect our perception of cause and effect in the cosmos? As scientists continue to explore these mysteries, the hope of finding a unified theory persists. Human curiosity is infinite, and the quest for answers to the deepest questions of the universe remains a powerful driving force. What discoveries await us in the future? Perhaps the key to understanding quantum gravity is closer than we think, waiting to be uncovered in the far reaches of the cosmos. The importance of resolving this dilemma lies not only in science but also in our understanding of the universe and our place within it. Every small advance in research can open new doors and offer a different perspective on the nature of reality. Are we ready to embrace the unknown and confront the mysteries that still surround us? With each new discovery, we come a little closer to understanding the vast and enigmatic universe. Quantum gravity could be the key that allows us to unravel the secrets of the cosmos, revealing not only how the universe works, but also who we are in this vast sea of stars. The search continues, and with it, the promise of new revelations that challenge our understanding and ignite our imagination. How cold can space be? Supercold vacuum is one of the most intriguing regions of the cosmos, where temperatures drop to unimaginable levels. But what does supercold really mean? Imagine a place where temperatures approach absolute zero, around minus 273 degrees Celsius. In this extreme environment, matter behaves in ways that challenge our notions of physics. We often think of cold as something we can feel, but in space, cold can be a much more complex concept. Regions of supercold vacuum are areas of the universe where matter is in an almost inert state. But what happens to energy in these frigid places? Why doesn't it behave as we expect? In these areas, energy seems to behave strangely, and the laws of physics we know may not apply in the same way. Scientists have found that in supercold vacuum, matter can exhibit quantum properties that we do not see under normal conditions. This raises fascinating questions. Could supercold vacuum be the key to understanding aspects of quantum mechanics that still elude us? Could it be a natural laboratory where the deepest secrets of the universe are revealed? One of the most intriguing aspects of supercold vacuum is its relationship with the expansion of the universe. As the cosmos expands, it cools, and this cooling can lead to the formation of regions where the temperature is much lower than expected. But what implications does this have for our understanding of matter and energy? Could it be that answers to questions that have puzzled scientists for decades lie in these areas? Astrophysicists have detected these regions through observations of cosmic radiation. As we explore beyond the limits of the known, new uncertainties arise. Why are some areas of space so cold? And how does this affect the formation of structures like galaxies and stars? Each answer seems to open the door to new questions, creating an endless cycle of discovery. A related phenomenon that has captured researchers' attention is the so-called cosmic microwave background radiation. This radiation, which fills the universe, is an echo of the Big Bang and exists in a state of extreme cold. However, variations in this radiation suggest that there is more to the universe than we can see. Could these variations be related to supercold vacuum? The study of these icy regions could also provide clues about dark matter and dark energy, two of the greatest mysteries of modern cosmology. If supercold vacuum plays a role in the structure of the universe, we could be on the verge of a significant breakthrough in science. But how can we investigate these remote and difficult-to-reach areas? Ground-based and space telescopes are designed to capture light from distant stars and galaxies. But studying supercold vacuum requires special tools. Scientists are developing advanced technologies to measure the properties of the vacuum, seeking answers in an environment where matter and energy behave unusually. Meanwhile, supercold vacuum also invites us to reflect on the nature of reality itself. If in these regions matter can behave so differently, what does that mean for our understanding of the universe? Are we truly in contact with the essence of matter, or are there levels of reality that we have yet to discover? Each new finding in the study of supercold vacuum can have profound implications for our understanding of physics. It could challenge us to rethink the foundations of science and open new avenues of research. But are we prepared to face what we discover? Exploring supercold vacuum is not just a scientific quest, but a philosophical exploration of our place in the cosmos. As we venture into the unknown, we must be ready to accept that some answers may be more perplexing than the questions themselves. What mysteries await us in the depths of the universe? The search for answers in supercold vacuum is an invitation to curiosity and wonder. It reminds us that the universe is a vast place full of secrets, and that each discovery is just another step in our adventure to understand it. As we move forward, we must keep an open mind and a heart willing to explore. In this journey, every question is as valuable as the answer we seek. So, as we contemplate supercold vacuum, let us remember that we are in a space where science and philosophy intertwine. Each discovery we make not only brings us closer to understanding the universe, but also invites us to reflect on our own existence and the mystery of life itself. What will all this mean for the future of humanity? What new frontiers will open as we continue our quest for knowledge? Have you ever heard of white holes? Imagine a phenomenon that is the opposite of a black hole. While the latter devours everything around it, white holes, according to theory, would expel matter into the universe. But what are they really, and why are they so intriguing to scientists? The idea of a white hole arises from Einstein's general relativity equations. If a black hole is a region of space where gravity is so intense that nothing can escape, a white hole would be a region where nothing can enter. This raises a fascinating question. Can these celestial objects really exist? Physicists have been debating this issue for decades, but so far, we have not found evidence of their existence. Imagine a white hole as a kind of cosmic fountain throwing matter and energy into space. However, the lack of direct observations leads us to wonder, why haven't we seen one? Some scientists suggest that these objects could be extremely rare or even ephemeral, existing only for a brief moment before fading away. Could they be hiding in corners of the universe that we have yet to explore? The theory of white holes also intertwines with the idea of information conservation. What happens to the information that falls into a black hole? According to some theories, it could be expelled again through a white hole. This raises a fascinating dilemma. If information is conserved, could there be a connection between black holes and white holes acting as two ends of the same phenomenon? Let's take a moment to reflect on the concept of time. In the context of white holes, time could be viewed differently. While a black hole might represent a point of no return, a white hole could symbolize a new beginning. But how does this fit into our current understanding of time and space? The idea that time could flow in opposite directions is a concept that challenges our intuition. As scientists continue to investigate, new questions arise. Could white holes be the key to understanding phenomena like dark matter or dark energy? Some theorists argue that they could be related to these cosmic mysteries. What implications would this have for our understanding of the universe? Another intriguing question is the relationship between white holes and wormholes. The latter are hypothetical shortcuts in space-time that could connect different points in the universe. If white holes exist, could they be related to the creation of wormholes? It's a puzzle that opens the door to numerous possibilities. It's natural to wonder if we will ever be able to observe a white hole. Technology is advancing rapidly, and what seems unattainable today could be possible tomorrow. Can you imagine the excitement of detecting one of these phenomena? The search for signals or hints of white holes could become a new goal for astronomers. Meanwhile, the scientific community continues to debate the validity of white holes. Some consider them mere mathematical curiosities, while others believe they could have a deeper role in the structure of the universe. What's your opinion? Do you think there is more to discover in the vast cosmos that surrounds us? At its core, the idea of white holes reminds us how little we know about our universe. It invites us to question our beliefs and keep an open mind. In such a vast and incomprehensible universe, there is always room for the unknown. What other mysteries await us in the future? Ultimately, the search for white holes reflects our innate curiosity to understand the unknown. As we explore the cosmos, we encounter questions that lead us to reflect on our own existence. What does it mean to be part of this vast universe full of mysteries? Science advances, but many questions remain unanswered. The search for white holes and other cosmic phenomena pushes us to keep exploring and never stop asking. What more can we learn from this universe that challenges our understanding? The story of white holes is just one of many pages in the book of the cosmos. As we continue to investigate, let's remember that every answer we find also generates new questions. Thus, the journey through the mysteries of the universe never ends, and there will always be more to discover. Are you ready to keep exploring? The anisotropic expansion of the universe is a phenomenon that invites curiosity and reflection. Have you ever wondered if the universe expands uniformly? The answer to this question could change our understanding of the cosmos. Although we are taught that the universe is expanding, the reality is more complex than it seems. Not all points in space are moving away from us at the same speed. Why is that? Imagine you are on a balloon. When you inflate it, the surface expands and all points move away from each other. However, what if I told you that in the vast cosmic ocean, things are not that simple? There are indications suggesting that some regions of the universe are moving away more quickly than others, as if they are in an uneven race. This idea, known as anisotropic expansion, raises intriguing questions about the very nature of our cosmos. What could be causing this strange behavior? Scientists have speculated that factors such as dark matter and dark energy might be influencing this uneven expansion. But what exactly are dark matter and dark energy? Despite making up a large part of the universe, they remain a mystery to us. Dark matter does not emit light or energy, making it practically invisible, while dark energy is even more elusive, acting as a force that accelerates the expansion of the universe. Now, how do we know that the expansion is not uniform? Observations of distant galaxies have revealed surprising patterns. By studying the light emanating from these galaxies, astronomers have noticed that some are moving away from us at much greater speeds than others. How can this be possible? The answer lies in the geometry of our universe. which may not be as simple as an expanding sphere. Instead, it could have a more complicated shape, like a wrinkled surface that deforms as it expands. This discovery not only challenges our notions of cosmology, but also suggests that there is much more to uncover. Could there be regions of the universe that behave completely differently? Some scientists believe there could be currents of expansion affecting groups of galaxies, creating a tidal effect that influences their movement. Imagine a river carrying logs in different directions, each one pulled by different forces. What other invisible forces might be operating in the depths of the cosmos? Anisotropic expansion also leads us to question the homogeneity of the universe. According to the Big Bang theory, the universe should be relatively uniform on a large scale, but observations indicate that there are large-scale structures that cluster and are not evenly distributed. Are we facing a universe that challenges this idea of equilibrium? It's a question that prompts us to explore the possibility that our cosmos is a much more dynamic and complex place than we think. Moreover, anisotropic expansion could have implications for the future of the universe. If certain regions are expanding faster than others, could this mean that some galaxies will be lost forever, escaping from our view? Perhaps in the future, some of the galaxies we see today will become distant memories, and the vastness of space will feel even lonelier. What does this mean for our understanding of time and the history of the cosmos? As we continue to explore these questions, scientists are still searching for answers. New technologies and telescopes are allowing us to observe the universe with unprecedented clarity, revealing details that were previously invisible. What discoveries await us in the future? Perhaps we will soon gain a clear answer to anisotropic expansion and its impact on our understanding of the universe. The nature of the expansion of the cosmos reminds us that, although we have made progress in our knowledge, there are still mysteries to solve. Science advances by leaps and bounds, but there are always questions that challenge our theories and push us to investigate beyond the known. How far will this journey of discovery take us? Ultimately, anisotropic expansion is not just a fascinating phenomenon. It is a reminder of the beauty and complexity of the universe. Each new discovery brings us one step closer to unraveling the secrets of the cosmos. But it also leaves us with more questions. What other mysteries lie hidden in the vastness of space? The search for answers continues, and the universe, in its immensity, remains an enigma to be solved. So the next time you look up at the stars, remember that there is a universe full of surprises that we have yet to decipher. Anisotropic expansion is just one chapter in the story of our cosmos, and each discovery opens a door to new questions. Are we ready to walk through those doors and discover what lies beyond? The adventure of knowledge never ends. Have you ever wondered if the universe we know is just a small bubble in a vast sea of realities? The idea of bubble universes has captured the imagination of scientists and dreamers alike. According to this fascinating hypothesis, our cosmos could be one among an infinite number of universes, each with its own physical laws and characteristics. But how is it possible for so many universes to exist? And most intriguingly, what does this mean for our understanding of reality? Imagine a great ocean where each bubble represents a distinct universe. Some bubbles may be similar to ours, with galaxies, stars, and planets, while others could be completely different, with forms of life and laws of physics that we can barely imagine. This concept challenges our notion of what is possible. How can we be sure that only one universe exists when the bubble universe model suggests otherwise? The idea of bubble universes arises from the theory of cosmic inflation, which posits that in the early moments after the Big Bang, the universe expanded incredibly rapidly. During that time, small fluctuations in space-time could have created separate bubbles that developed independently. Each bubble may have different properties. Some could be hostile to life, while others might be similar to our home on Earth. But how could we detect the existence of these other universes? The answer is that science still does not have a definitive way to observe what lies beyond our cosmos. However, some theoretical physicists suggest that by studying the cosmic microwave background radiation, we might find clues about interactions between different bubbles. Can you imagine finding a signal from a neighboring universe? The possibility is both exciting and unsettling. Bubble universes are not just a theoretical concept. They also raise profound questions about the fate of our own universe. If there are infinite universes, what is the purpose of ours? Is it simply one of many, or is there a deeper meaning behind our existence? These philosophical questions resonate in the minds of many as each answer opens up even more inquiries. In this context, it is fascinating to consider the idea of the multiverse, which refers to a set of universes that may include bubble universes, parallel universes, and perhaps other types of realities that we have yet to imagine. This concept challenges not only our scientific understanding, but also our beliefs about life and destiny. If there are other universes, do we have versions of ourselves living completely different lives in those worlds? However, the notion of bubble universes also faces criticism. Some scientists question whether there is really enough evidence to support this theory. Science, after all, is based on observation and experimentation. If we cannot see these other universes, do they really exist? This question poses a fascinating dilemma. Is science capable of exploring and validating concepts that are beyond our physical reach? As we explore the idea of bubble universes, it is essential to consider how they affect our understanding of time and space. In a multiverse, time might not be linear, and dimensions could behave in ways we have never observed. What implications would this have for our perception of time? Could there be universes where time flows in opposite directions, or where it does not exist at all? The notion of bubble universes also has cultural and philosophical appeal. In literature, film, and philosophy, the idea of other universes has been explored in multiple ways, from science fiction stories to deep reflections on human destiny. Why do we feel such an intense connection to the possibility of other worlds? It is as if, deep down, we long to understand that we are not alone in the vast cosmos. Moreover, if we consider that bubble universes are constantly expanding and evolving, this leads us to question the nature of creation itself. What does it mean to be part of a universe that could be connected to other universes? The idea that our cosmos is a fragment of something much larger invites us to reflect on our own existence and the place we occupy in the grand scheme of the cosmos. The exploration of bubble universes also highlights the importance of human curiosity. Throughout history, humanity has sought answers to the deepest questions about our origin and destiny. Science has provided us with tools to investigate and understand our environment, but it has also led us to consider concepts that transcend our current understanding. What discoveries await us in the future? What mysteries still lie ahead at the frontiers of knowledge? In conclusion, the idea of bubble universes invites us on a fascinating journey into the unknown. It challenges us to reconsider our beliefs about reality and to open our minds to possibilities that once seemed unimaginable. As we continue to explore the cosmos, let us remember that every question we ask brings us one step closer to the truth, and that in the vast ocean of existence we might discover much more than we ever dreamed. The quest for knowledge is an endless journey, and the mysteries of the universe are the beacons that illuminate our path. What is dark radiation? This mystery has captured the imagination of scientists and universe enthusiasts alike. While we are all familiar with dark energy, which drives the acceleration of the universe's expansion, dark radiation represents a much more enigmatic and poorly understood field. Could it be that this unknown form of energy played a crucial role in the early evolution of the cosmos? Imagine the universe as a vast ocean of matter and energy. In this ocean, dark energy acts as a wind that pushes the waves outward. But what if there were an invisible underground current that affects how those waves move? That is the essence of dark radiation. Although we cannot see it, its presence could be fundamental to understanding the universe's past. Scientists have found hints that dark radiation might be related to the behavior of galaxies in their early stages. Why do some galaxies seem to move differently than others? The answer could lie in this yet-to-be-identified form of energy. Imagine a kind of energy halo surrounding galaxies, influencing their movement and how they interact with each other. Dark radiation could be the key to solving a cosmic puzzle. If we consider that the universe is approximately 13 billion years old, how is it possible that it has continued to expand so rapidly? This is where dark radiation comes into play. Some theorists suggest that it may have existed in large quantities in the early moments after the Big Bang, acting as a catalyst in the formation of complex structures. But how does this relate to the visible matter we know? The matter that makes up stars, planets, and galaxies is only part of the... Have you ever felt that the universe holds secrets that challenge our understanding? One of those enigmas is what is known as dark flow. Imagine a vast sea of galaxies, each moving through space, but the curious thing is that some seem to have trajectories that make no sense. What causes these galaxies to move in such strange ways? The answer to this question leads us to a mystery that has intrigued scientists for decades. The first clue about dark flow emerged when astronomers observed that certain galaxies were moving in directions that defied our expectations based on gravity. In a universe where everything seems governed by precise laws, why do some galaxies appear to dance to the tune of an unknown melody? This phenomenon has led to the theory that there are hidden forces that we do not fully understand, influencing the way these galaxies move. Dark flow is not simply a whim of nature. In fact, it has been detected on such large scales that it is difficult to ignore. Studies have shown that in vast regions of the cosmos, galaxies seem to move together as if being pulled by an invisible tug. What could be causing this movement? Some theories suggest that there may be large structures of matter that are not visible, known as dark matter. But what about dark matter? Dark matter is a fundamental component of the universe that does not emit light or radiation, making it practically undetectable. However, its gravitational influence is undeniable. While we know that dark matter exists, we do not know exactly what it is made of. So when we talk about dark flow, we are also talking about dark matter and how it may be organizing the movement of galaxies. Furthermore, we must consider that dark flow might also be related to dark energy, another of the great unknowns of the cosmos. This mysterious form of energy is believed to be behind the acceleration of the universe's expansion. Could it be that dark flow and dark energy are connected in some way? These questions are at the core of current research in cosmology. A fascinating aspect of dark flow is that it does not only affect one galaxy or a group of them, but has been observed on large scales, suggesting that it is present throughout the universe. This effect has led scientists to wonder if we truly understand the large-scale structure of the cosmos. Is it possible that the universe is organized in a way that we have yet to decipher? As astronomers continue to explore this phenomenon, new theories have emerged. Some suggest the existence of filaments of dark matter connecting groups of galaxies, forming a kind of cosmic web. But how can we test these ideas? The answer lies in observation and the collection of data from increasingly powerful telescopes. Technology is advancing, and with it, our ability to see farther and clearer. As we delve deeper into the study of dark flow, we face questions about the very nature of the universe. Is it possible that there are forces we have yet to imagine? What implications would it have for our understanding of physics if these forces were real? Each new answer found opens the door to more questions. The search for dark flow also leads us to reflect on the history of the universe. How did we get here? The answer to that question involves a journey through billions of years of cosmic evolution, where each galaxy has played a role in the narrative of the universe. From its formation to its current movement, every element of the cosmos has its story to tell. And let us not forget that this mystery is not only a challenge for scientists, but also invites the curiosity of all of us. As we look up at the starry sky, we may wonder what other surprises the universe has in store for us. How many more secrets are waiting to be discovered? Are we prepared to face the answers that could change our understanding of reality? As we move forward on this journey, it is vital to remember that each discovery brings us closer to unraveling the mysteries of the cosmos. Science is a continuous process, and each answer leads us to new questions. Like an endless cycle of exploration, dark flow with its aura of mystery reminds us that there is still much to learn and discover in the universe. As you conclude this section, it is impossible not to feel a mix of awe and humility. The universe is vast and complex, filled with enigmas that challenge our imagination. And while dark flow may seem like an abstract concept, it is an invitation to keep exploring, to keep questioning, and to keep marveling at the immensity of the cosmos. Remember, every star you see in the sky may be connected to a mystery yet to be solved, and perhaps one day, that mystery will reveal to us the true workings of the universe. What if I told you that we could be surrounded by dimensions we have never experienced? In the vast and mysterious universe, the idea of extra dimensions has captured the imagination of scientists and philosophers alike. But what are these additional dimensions really? And most intriguingly, why might they exist? Modern physics, especially string theory, suggests that our universe is not limited to the three spatial dimensions we perceive. In this model, it is proposed that hidden dimensions exist, often described as extra. But how can we understand something that we cannot see or touch? It is definitely a challenge, but it is a challenge worth exploring. Imagine that the dimensions we know are just a small part of a vast puzzle. The three dimensions we experience, daily, length, width, and height, are merely the surface of a much more complex phenomenon. According to some theorists, there could be as many as 10 or more dimensions in total, but where are they? Why don't we see them? And more importantly, what does that mean for us? It has been suggested that these extra dimensions are curled up, compacted at scales so small that they are practically undetectable to our senses. Visualize a garden hose. When you look at it from a distance, it appears to be a one-dimensional object, a line, but if you get closer and look closely, you can see that it has a diameter and therefore a third dimension. In the same way, the extra dimensions could be like those twists and folds that we cannot observe at first glance. But why is it important to consider these additional dimensions? The answer lies in the quest for a unified theory that can explain all the forces of nature. Gravity, electromagnetism, the strong nuclear force, and the weak nuclear force are the four fundamental forces that govern the universe. However, each operates under different principles. Could these extra dimensions be the key to understanding how these forces interact? Imagine that each additional dimension could influence how these forces behave. What if gravity, for example, were not simply a force acting in three dimensions, but also extended into other dimensions that we cannot perceive? This could help resolve some of the deepest mysteries of modern physics, such as the nature of gravity and its relationship with quantum mechanics. The idea of extra dimensions could also have fascinating implications for cosmology. If the universe has more dimensions than we can see, this could change our understanding of the formation and evolution of the cosmos. Could there be other universes, each with different physical laws, coexisting alongside ours, separated by dimensions we cannot traverse? And not only that, the concept of additional dimensions also raises questions about the nature of reality itself. If our universe is just a slice of a much more complex fabric, what does that mean for our perception of time and space? Are we limited by what we see, or is there much more at play? Perhaps what we consider real is just a fraction of what truly exists. Some scientists have even explored how these extra dimensions could influence matter and energy. In theory, they could offer explanations for phenomena we currently do not understand, such as dark matter and dark energy. Could it be that these mysterious entities are merely manifestations of dimensions we cannot directly perceive? However, the idea of extra dimensions is not without controversy. Many in the scientific community are skeptical. After all, the lack of direct evidence makes it a difficult concept to accept, but that does not mean it is not worth investigating. Exploring additional dimensions could be the next great breakthrough in our understanding of the universe. Ultimately, the search for extra dimensions is more than just a scientific question. It delves into the realm of philosophy and metaphysics. What does it really mean to exist in a cosmos where there could be much more than we can see? How does this change us as human beings? Reflecting on these questions can open the door to new ways of thinking about our place in the universe. As we continue to explore these mysteries, it is essential to keep an open mind and a curious spirit. Science advances as we ask questions and seek answers. Each discovery brings us one step closer to unraveling the secrets of the cosmos. And who knows what revelations await us along the way. So the next time you look up at the starry sky, remember that you might be observing only a fraction of reality. The extra dimensions could be all around you, waiting to be discovered. Are you ready to keep exploring the unknown? The universe is a place full of surprises, and the answers we seek might be closer than we think. What is primordial plasma, and why is it so fascinating? To understand it, we must go back in time, right after the Big Bang, when the universe was a radically different place. In those early moments, conditions were extreme, incredibly high temperatures and unimaginable density. But what does this mean in terms of matter? The answer is simple: primordial plasma. In this state, matter did not exist as we know it today. Instead of atoms and molecules, we had a hot soup of subatomic particles, primarily electrons, quarks, and gluons. Why do scientists believe this plasma is so important? Because it is argued that this early phase of the universe was crucial for the development of everything we see today. Imagine a blank canvas where everything begins. Physicists believe that as the universe cooled, these particles began to combine, forming the first atomic nuclei. But what happened next? Over time, these nuclei joined with electrons, thus creating the first atoms, primarily hydrogen and helium. Without primordial plasma, the universe would not have had the opportunity to evolve into the complexity we observe today. But how do we know this primordial plasma existed? Through cosmic background radiation, which is like an echo of the Big Bang. This radiation gives us clues about the initial conditions of the universe. By studying this radiation, scientists have been able to infer the temperature and density of primordial plasma. However, there are still many unanswered questions. Why did this plasma behave the way it did? What physical laws governed that state? Additionally, scientists face the enigma of how primordial plasma transitioned to a more ordered state. What mechanisms allowed matter to organize so effectively? Despite advances in physics, this process remains a puzzle. Some researchers have proposed that quantum gravity, which seeks to unify gravity with quantum mechanics, could offer answers, but there is still no consensus. An intriguing aspect of primordial plasma is that it might contain clues about dark matter. This form of matter, which does not interact with light and is therefore invisible, seems to be fundamental to the structure of the universe. Some scientists believe that primordial plasma could have influenced the formation of this dark matter, but how can we investigate something we cannot see? The answer may lie in experiments at particle accelerators and the observation of astrophysical phenomena. As the universe expanded and cooled, the interactions between the particles of plasma began to change. A fascinating question arises: what effects did this transition have on the formation of galaxies? It is believed that primordial plasma established the necessary conditions for gravity to start acting on matter. This led to the formation of large-scale structures in the universe, but what were the exact steps that led to this? The answer remains a subject of research. Another question that arises is, what does primordial plasma tell us about the very nature of time and space? In those early moments, time as we understand it may have had a completely different meaning. Some theories suggest that time could have begun with the Big Bang. If this is true, then primordial plasma is not just a state of matter, but also a crucial moment in the history of time. As we explore more about primordial plasma, we arrive at an idea that challenges our understanding: the possibility that multiple states of plasma exist in the universe. Could there be other plasmas in extreme conditions that we have not been able to observe? Scientists are beginning to investigate this, and each new discovery opens doors to more questions about the nature of the cosmos. Research on primordial plasma also has implications for technology. Understanding how matter behaves under extreme conditions could inspire new advances in physics and engineering. How could this knowledge help us develop innovative technologies? The answer may lie in the creation of new materials or in improving our energy systems. Finally, primordial plasma invites us to reflect on our own existence. Where do we come from? What connects us to the universe as a whole? Exploring these states of matter reminds us that we are part of a vast and ever-changing cosmos. It drives us to continue seeking answers, to keep asking questions, and to never cease marveling at the immensity of the universe. Thus, the study of primordial plasma not only provides us with information about the early moments of the universe, but also challenges us to explore the limits of our knowledge. Every answer we find brings with it new questions. And in this journey of discovery, what seems to be a simple state of matter becomes a window into the deepest mysteries of the cosmos. The story of primordial plasma is just the beginning of a much larger narrative, one that is waiting to be told. Have you ever felt that the universe is a place full of surprises and mysteries that challenge logic? One of those enigmatic phenomena is phantom energy. But what exactly is it, and why is it so intriguing? Imagine there exists a form of energy so exotic that it could have the power to dismantle everything we know. Sounds terrifying, right? Phantom energy, in theory, could be even more powerful than dark energy. That mysterious force that seems to be accelerating the expansion of the universe. But how did the idea of phantom energy arise? Scientists have been trying to understand the nature of dark energy since it was observed that the universe is expanding at an increasing rate. This acceleration has left a series of unanswered questions. If dark energy is responsible for this expansion, what if there was something even more powerful that could reverse that process? Something like phantom energy could be a terrifying answer to this question. Phantom energy is characterized by its negative density. This means that instead of attracting matter, it could repel it. Imagine a universe where gravity does not act in the way we know. What implications would this have for the formation of galaxies and the structure of the cosmos? The idea that an invisible force could destabilize everything we have come to understand is undoubtedly unsettling. What happens if phantom energy becomes a reality? Some scientists suggest it could lead to an apocalyptic scenario known as the Big Rip. In this hypothetical event, the forces of phantom energy could become so intense that they would unleash an irreversible, accelerated expansion. Can you imagine a universe where galaxies move away from us at such a speed that we can never see them again? Such a future is hard to conceive, but experts consider it a real possibility. Phantom energy is not only intriguing for its potential cataclysmic effects, but also because it leads us to question how matter and energy behave in the cosmos. Do we really understand how the laws of physics work in the universe? As we explore these questions, we realize that phantom energy could be the key to unlocking secrets about the very nature of reality. Moreover, phantom energy pushes us to think about what vacuum means. If the vacuum is simply a space without matter, could it actually be filled with forms of energy that we have yet to discover? Some scientists believe there could be fluctuations in the vacuum that give rise to phantom energy. These fluctuations could be what maintain a delicate balance between matter and energy in the universe. But here is where the story gets complicated. Phantom energy is not just a theory, it also poses a philosophical dilemma about our place in the universe. If everything we know can be dismantled by a force we do not fully understand, how can we claim to truly know the cosmos? This question is fundamental and invites us to reflect on our own existence and the role we play in the vast cosmic stage. Scientists are in constant search of evidence that could support the existence of phantom energy. However, so far its nature remains elusive. This leads us to wonder, could it be that there are aspects of physics that we simply have not managed to decipher? Every finding in modern physics can open the door to new questions, and phantom energy is a clear example of this. Phantom energy also leads us to reflect on the connection between science and philosophy. What does this mean for the future of humanity and its quest for knowledge? If phantom energy is a reality, it could change our understanding of time, space, and life itself. Great thinkers have always sought answers to profound questions, and phantom energy is just one of many unknowns that could redefine our view of the universe. As we advance in our quest for answers, it is important to remember that each mystery brings us closer to understanding our own existence. Phantom energy is not just an abstract concept, it is a reminder that the universe is full of surprises. With each step, we encounter new questions that challenge our most fundamental beliefs. In summary, phantom energy is a fascinating enigma that invites us to explore the unknown. As we continue our exploration of the cosmos, we must keep an open mind to the possibility that what we think we know may be just the tip of the iceberg. The pursuit of knowledge is an endless journey, and each discovery brings us closer to understanding the secrets of the universe. So, the next time you look up at the starry sky, remember that there are mysterious forces operating in the cosmos. Forces that we have yet to fully comprehend. Phantom energy is just one of the many enigmas that await us, and each of them is an opportunity to expand our boundaries of knowledge. Who knows what other mysteries lie hidden in the vastness of the universe? The vastness of the cosmos harbors enigmas that so far challenge our understanding. One of the most intriguing is the concept of wormholes. What are they exactly? Imagine tunnels in the fabric of space-time that could connect different points in the universe. Sounds fascinating, right? But could they really exist? The idea of wormholes arises from the theories of general relativity by Albert Einstein, which suggest that space and time are not mere straight lines, but rather a flexible fabric that can be manipulated. This raises the question, if we could find one of these tunnels, could we travel instantly to distant places in the universe? The answer is perhaps. And that is why this idea has captured the imagination of scientists and dreamers alike. However, here comes the complicated part. Although the theory suggests that these shortcuts in space-time could exist, we have not yet been able to observe any. Why? The answer may be related to the stability of these wormholes. It is believed that for a wormhole to be useful, it would need to be held open by a form of exotic matter, something we have not found in nature. But what is exotic matter? Exotic matter is a concept that challenges our usual notions of matter. It is thought to have strange properties, such as negative energy, that would allow a wormhole to remain open. But so far, it exists only in the realm of theory. Could it be that the universe is telling us that wormholes are just a dream, or is there something more that we have yet to discover? Imagine the possibilities if they really existed. How would they change our understanding of space travel? We could explore distant star systems in a matter of seconds, cross galaxies in the blink of an eye. But what would happen to time? Would traveling through a wormhole mean we could travel to the past or the future? These questions lead us to even more intriguing territory. Traveling through wormholes raises fascinating dilemmas. If we could go back in time, would we have the power to change history, or would we be doomed to repeat it? Science fiction has explored these ideas in depth, but the reality is that we do not have definitive answers. Wormholes are not just a topic of fantasy, but a true mystery that invites us to reflect on the nature of time and space. And if we consider the existence of multiple universes, the idea of wormholes becomes even more complex. Imagine that a wormhole not only connects different points in our universe, but could also open a bridge to other realities. What if in another dimension there existed a version of yourself? What decisions would you have made differently? This concept is as intriguing as it is perplexing. Moreover, the study of wormholes could offer clues about the very nature of gravity, if we manage to understand how they work and how they could be stabilized. We could discover new forms of energy and matter that would completely change our understanding of the universe. But this leads us to a crucial question. Are we really prepared to handle such knowledge? As we continue to investigate, wormholes remain on the frontier between science and science fiction. The search for evidence supporting their existence is a path filled with challenges, and yet the mere idea that they could exist pushes us to keep exploring. to question what we know, and to open our minds to the unknown. In this journey into the unknown, it is essential to remember that every discovery in science begins with a question: what else is out there? What mysteries have we yet to unravel? The exploration of wormholes is just one part of a much larger cosmic puzzle. Perhaps one day we will discover that these tunnels in space-time are the key to understanding not only our universe but also the secrets of time and reality itself. So, in our quest for knowledge, let us keep asking and exploring. Every answer we find only leads us to new questions, and that is what makes the exploration of the cosmos so exciting. Wormholes may be just one more mystery, but they are a reminder that in the vast universe there is always something more to discover. Let us keep curiosity alive and continue seeking answers in the immensity of space. What is the mystery hidden behind the dilemma of cosmic entropy? Why does it seem that the universe has transitioned from a state of order to one of chaos so quickly and bewilderingly? Entropy, in simple terms, refers to the measure of disorder in a system. In our daily lives, it is easy to observe this phenomenon. A tidy room tends to become a messy place over time. But what does this mean on a cosmic scale? Since the beginning of the universe, approximately 13,800,000,000 years ago, everything started in a state of incredible density and temperature. At that moment, the cosmos was filled with energy and particles in constant agitation. However, as the universe expanded, those particles began to cool and form more organized structures: stars, planets, and galaxies. Yet how is it possible that something so orderly emerged from such a chaotic state? Scientists have developed theories to try to understand this process. On one hand, some suggest that the entropy of the universe has gradually increased over time. According to this idea, the universe began as a highly ordered system, and as it expanded, disorder grew. But here arises an intriguing question. Are we really sure that the universe started in a state of order? Let's imagine for a moment the Big Bang, that instant when everything began. Could it be that, in reality, the universe was already in a state of chaos before that initial explosion? Some physicists speculate that what we know as the Big Bang might have simply been an event marking a transition in a larger cycle. A cycle in which the universe expands and contracts indefinitely. If this is true, entropy could be an inherent characteristic of the universe, something that has always been present. But how does all this relate to what we see in our current environment? When we observe the night sky, we count thousands of stars and galaxies. However, on a large scale, the universe appears to be in a state of chaos. Galaxies are moving away from each other, some collide, and others group into clusters. Is this disorder a sign that the universe is, in fact, increasing its entropy? The question becomes even deeper when we consider the ultimate fate of the universe. Some theorists suggest that in the future, the cosmos could reach a state of thermal death, where all energy would be distributed evenly and no more processes would generate order. This would lead to a state of complete entropy, absolute chaos. However, could there be something that prevents this from happening? Scientists are investigating whether there are factors that could reverse or modify this path toward chaos. For example, the existence of still unknown forces that could act on matter and energy. Could it be that there is some kind of hidden order in the universe that we have yet to discover? If so, we might be in search of a key that allows us to understand how the balance between order and chaos is maintained. Another question that arises is, how do the interactions of particles influence the overall entropy of the universe? In the quantum realm, particles seem to behave in ways that challenge our usual understanding. Could it be that the quantum properties of matter play a crucial role in how entropy develops? Quantum mechanics offers a world of possibilities that we have not yet fully explored. Black holes also add an interesting nuance to this dilemma. The idea has been raised that these mysterious objects could be connected to entropy in ways we do not fully understand. For example, the surface area of a black hole is related to the amount of information it contains, suggesting that, in a sense, entropy could be stored in these objects. What implications would this have for our understanding of the universe? As we explore the dilemma of cosmic entropy, we also encounter the question of information. What role does information play in the balance between order and chaos? Some theorists argue that information could be fundamental to understanding the evolution of the universe. If this is true, could there be ways to recover order from chaos by effectively using information? As we delve into these questions, it becomes clear that the dilemma of cosmic entropy is not just a scientific issue, but also a philosophical one. It confronts us with the very nature of the universe and our understanding of what it means to exist within it. Are we doomed to a chaotic future, or is there hope for renewed order in the vast cosmos? As we continue to seek answers, it is evident that cosmic entropy is a reminder of the complexity of the universe. It invites us to reflect on our position in the grand scheme of the cosmos and to consider the possibilities that are still yet to be discovered. Could it be that, in the end, the true mystery is not chaos itself, but our ability to understand it and find meaning amid uncertainty? So the next time you look up at the starry sky, remember that each star and each galaxy is part of a vast web of order and chaos. Cosmic entropy offers us a unique perspective on the nature of the universe and the eternal quest for knowledge that drives us to continue exploring the mysteries that surround us. How far our observable universe extends is an enigma that has intrigued scientists and philosophers alike. What lies beyond the cosmic horizon? This concept, which may seem abstract, is fundamental to understanding the nature of the cosmos. The light from the most distant stars and galaxies we have the opportunity to see has traveled billions of years to reach us. But what about those places we have yet to observe due to the limitation of the speed of light? The observable universe is defined as the region of space we can see, limited by the distance that light has been able to travel since the Big Bang. But what happens beyond that limit? Imagine a vast ocean in which we have only explored a small part. As our telescopes become more powerful, we begin to glimpse beyond what was previously possible. However, there is always a frontier we cannot cross. That frontier is the cosmic horizon. Theories suggest that the universe could be much larger than we can perceive. Could it be that there are regions of space expanding outward, moving away from us at such a speed that we will never be able to observe them? The expansion of the universe, which began with the Big Bang, continues its course, and some parts are so far away that the light they emit will never reach our eyes. This raises a fascinating question. Are there more galaxies, stars, and perhaps even forms of life in those inaccessible regions? The idea of an infinite universe is both awe-inspiring and perplexing. If the universe is truly infinite, does that mean there are an infinite number of worlds to discover? Furthermore, if we assume that the universe is finite, what lies at the edges of that universe? The notion that we could be surrounded by an endless void is difficult to accept. Is it possible that beyond what we see there are other dimensions, other universes, or even nothing at all? Modern cosmology also presents us with dilemmas about the shape of the universe. Some models suggest that the cosmos is flat, while others indicate that it could be curved. If the universe is curved, could it be that by traveling in one direction, we eventually return to our starting point? This concept of a closed universe raises new questions about the nature of space and time. Additionally, some suggest that the observable universe could be just a small fragment of a multiverse. Imagine that each universe has its own rules, dimensions, and physical laws. In those other universes, reality could be completely different from ours. What if there were infinite universes where every decision we make creates a new reality? This scenario, while fascinating, is also deeply unsettling. The cosmic horizon also poses questions about the future of the universe. As the universe expands, there will come a point when galaxies will move so far away that they will become invisible to us. In the distant future, we might find ourselves in a universe where we can only see a fraction of what exists. How will this affect our understanding of the cosmos and our place within it? Some scientists believe that the universe could be in a state of accelerated expansion. This means that it is not only moving away but doing so at an ever-increasing rate. How can this be? One theory that has been proposed is the existence of a mysterious form of energy known as dark energy, which could be responsible for this acceleration. However, its true nature remains a mystery. The radiation we receive from the cosmic microwave background is an echo of the Big Bang, a trace of the universe's early moments. This cosmic whisper offers us clues about its origin and evolution. But what secrets may lie beyond what we can observe? Science progresses, and with it, our methods for investigating the cosmos, but there will always be that veil separating us from the unknown. Each new discovery leads us to ask even more questions. As we explore the universe, each answer seems to open the door to new uncertainties. Will we ever catch a glimpse of what lies beyond the cosmic horizon? Human curiosity is insatiable, and that quest for knowledge is what drives us to continue exploring and questioning our place in the vast universe. It is fascinating to think about how this quest has shaped our history, from ancient civilizations looking to the stars for answers to modern telescopes that allow us to look back in time through the light of galaxies. Science and philosophy intertwine in this search, and each new finding brings us a little closer to understanding the immensity of the cosmos. Ultimately, the limit of the observable universe is a reminder of how little we truly know. Curiosity is what drives us to keep exploring, and while the cosmic horizon may seem like an end, it is actually just a new beginning. The story of the universe is a story of discovery, and every question that arises is an invitation to keep probing and marveling at the unknown. So, as we advance in our understanding of the universe, let us remember that every mystery we solve leads us to another, even deeper one. The pursuit of knowledge is, and always will be, an endless adventure. What else will the cosmos reveal to us in its vast and enigmatic expanse? What if I told you that the universe is much more mysterious than we can see at first glance? In the world of physics, there exists a fascinating theory that takes us to the edge of the unknown: supersymmetric particles. But what exactly are these particles, and why are they so important for understanding the cosmos? Imagine a universe where every particle we know has a companion, a kind of twin that we have not been able to detect. This is the essence of supersymmetry, a theory that suggests that the fundamental particles of nature are not alone. But why do we need these twins? The answer lies in the enigma surrounding dark matter and dark energy, two components that make up most of the universe but that we still do not fully understand. Scientists have proposed that supersymmetric particles could be the key to unraveling these mysteries. If they existed, they could interact with normal matter in ways we have not yet observed. But where are these particles? Despite decades of searching in particle colliders like the Large Hadron Collider, we have still not managed to detect them. This raises a troubling question. Could they be in a state we have yet to imagine? Moreover, supersymmetric particles are not just a matter of scientific curiosity. They could have profound implications for our understanding of the universe. If these particles exist, they could help explain why the universe has the amount of matter it does and how it has been structured over time. However, if we fail to find them, we would have to rethink our fundamental theories about physics. But supersymmetry is not just an abstract concept. The idea that the universe could be filled with these hidden particles invites us to think about our place in the cosmos. Are we alone in our understanding of reality? Is there more than we can perceive waiting to be discovered? The search for these particles is a journey into the unknown, where each answer could lead us to new questions. Imagine a world where the physics of the small and the large merge. Supersymmetric particles could be the bridge connecting quantum mechanics with gravity, two forces that have so far remained on opposite sides of the field of physics. This union would not only be a milestone in science, but would also give us a more complete view of how the universe works. However, not everything is optimism. Skeptics argue that supersymmetry is a theory that has become increasingly difficult to uphold, especially in the absence of evidence. Could it be that we are trapped in a maze of theories that lead nowhere? This uncertainty is part of what makes exploring the universe so exciting and terrifying at the same time. The search for supersymmetric particles reminds us that despite our advances, there is still much we do not know. Each failed experiment brings us closer to the truth, even if it sometimes feels like we are moving backward. How can we continue then in this endless search? The answer may lie in human perseverance and ingenuity. Science is a path filled with obstacles, but each one teaches us something new. What if these particles were in a place we have never looked? In the vast universe, there are many unexplored regions. Perhaps the key to understanding supersymmetry does not lie in the laboratories of Earth, but in space itself, where extreme conditions may have allowed for the creation of these particles. Space exploration could open doors we never imagined. The idea that the universe could be filled with layers of reality that we cannot see is fascinating. Every time we look up at the stars, we wonder what else might be beyond what is presented to us. Supersymmetry is just one of many theories that attempt to explain the inexplicable, but its search is a reminder that human curiosity is infinite. Science does not stop. It advances with every question, every discovery, and every failure. The search for supersymmetric particles challenges us to keep questioning, to keep exploring. And although we may not yet have definitive answers, the fact that we are searching is already a significant step forward. As we delve into the vast ocean of knowledge, let us remember that each mystery solved brings with it new questions. Supersymmetry is just one of many doors yet to be opened in the universe. Who knows what we might discover if we continue searching, if we keep our minds open to the unknown? So what does the future hold in our quest for these mysterious particles? The answer could change our understanding of the universe in ways we cannot yet imagine. Every day is a new opportunity to explore, to challenge our limitations, and to discover what remains hidden. The adventure has only just begun. What is the reason behind the laws that govern our universe? It is a question that has intrigued scientists and philosophers for centuries. Since the moment humanity began to observe the stars, fundamental questions about the nature of reality have arisen. Why does gravity attract objects? What makes light travel at a constant speed? These are just some of the concerns that lead us to inquire about the origin of physical laws. The laws we know seem to be a set of universal rules, applicable in every corner of the cosmos. But where do they come from? Are they simply a feature of our universe, or is there a deeper background that we have yet to understand? The idea that these laws could be the result of intentional design or a cosmic accident is both fascinating and perplexing. Some scientists suggest that the laws could be a consequence of the intrinsic properties of the universe itself. But what does that really mean? Imagine a universe that could have had different physical rules. What if gravity were weaker, or if light did not exist? The very existence of life as we know it could be impossible in such an environment. The idea that these physical laws are fixed and immutable is a concept we must question. Is it possible that in other parts of the universe or in parallel universes the laws are completely different? This speculation leads us to think about the possibility that what we consider reality is just one of many versions of existence. But how can we prove something so abstract? Physicists have tried to answer these questions through theories that attempt to unify the fundamental forces. One of the most ambitious is string theory, which suggests that subatomic particles are not points, but vibrating strings. But what does this imply for our physical laws? If the strings vibrate in different ways, they could give rise to different laws in different universes. However, string theory is not the only answer. There is also quantum gravity theory, which seeks to unite quantum mechanics with general relativity. Why is it so difficult? The struggle to find a theory that explains how the universe works at a more fundamental level reveals how complex reality is. Perhaps the laws are simply a reflection of our inability to comprehend the deeper mysteries of the cosmos. As we explore beyond the known, we encounter the notion that physical laws may not be universal. Could they vary in time or space? Some theories suggest that, in the early moments after the Big Bang, the laws we know might have been different. Imagine a universe where the rules changed constantly. How would this affect the evolution of galaxies, stars, and of course, life itself? The study of the origin of physical laws also touches on the field of philosophy. The question of why the universe obeys these laws and not other possible ones leads us to reflect on the nature of existence. Are we destined to uncover all the secrets of the cosmos, or are there limits to our knowledge? The search for answers could be endless, and each answer found could open the door to new questions. The fact that physical laws are so precise and consistent across time and space is, in itself, a mystery. Why does the universe behave so orderly? This regularity has allowed scientists to develop models and theories that describe the workings of the cosmos. However, the question of their origin remains unanswered. Perhaps it is a reflection of an underlying order that we have yet to fully comprehend. As we continue to explore the cosmos, the possibility that other physical laws exist in parallel universes invites us to imagine a multiverse. What forms would those universes take? Would they have life? Could they be so strange that our minds could not conceive the forms of existence that might prevail there? These are questions that open a range of possibilities that challenge the limits of our imagination. Ultimately, the enigma of the origin of physical laws may be one of the deepest questions we face as humanity. It reminds us that although we have made great strides in science, there remains a vast ocean of the unknown to explore. The search for these answers is what drives our curiosity and our desire to understand the cosmos. So the next time you look up at the starry sky, remember that behind every star, behind every galaxy, there is a mystery waiting to be discovered. The story of the laws of the universe is still an unfinished narrative, and we are part of that endless quest to understand our roots and our place in the vast expanse of space. The vastness of the universe offers us a panorama filled with enigmas and mysteries that to this day we have not managed to solve. What lies beyond what we know? Are there hidden answers in the stars that we have yet to discover? The pursuit of knowledge is an endless journey, and each answer we find only leads us to new questions. When observing the night sky, one question arises immediately: why is the universe the way it is? The physical laws that govern our existence are in many ways a reflection of a complex and often inexplicable order. Why are these laws the ones that prevail and not others? It is a dilemma that invites us to delve into the very essence of the reality we inhabit. The mystery of dark energy and dark matter reminds us that although we have advanced in our understanding of the cosmos, much of it remains a puzzle. What role do these invisible forces play in the expansion of the universe? As scientists attempt to unravel these secrets, we are faced with the astonishing possibility that the universe is full of surprises, waiting to be discovered. And speaking of surprises, what about wormholes? These shortcuts in the fabric of space-time have captured the imagination of many. If they truly exist, could they be the key to traveling through time and space? However, even if they are found, how could we use them without endangering our existence? Science fiction has explored these ideas for decades, but reality may be even stranger than we can imagine. Bubble universes are another fascinating idea that raises the possibility that our cosmos is not the only one. If there are infinite parallel universes, what would they look like? Could there be a version of ourselves in one of those universes making different decisions? The multiverse theory opens up a range of possibilities that challenge our understanding of reality. The enigma of cosmic entropy leads us to reflect on the fate of the universe. If everything tends toward chaos, is there any hope that life and order can persist amid this disorder? Questions about the future of the cosmos are as intriguing as those we ask about its origin. As the universe expands, could there come a time when everything is so dispersed that life is just a distant memory? On the other hand, the dilemma of quantum gravity reminds us that there is still much to discover in the realm of physics. Is it possible to unify gravity with quantum mechanics? The search for a unified theory could open the door to a deeper understanding of the nature of the universe. Could it be that the answer lies in a corner of the cosmos that we have yet to explore? In this journey of discovery, we also encounter the mystery of extra dimensions. What would it mean for us if there were indeed dimensions beyond the three we know? The idea that there is more to the universe than we can perceive is both perplexing and fascinating. Could there be parallel realities to our own, waiting to be explored? Moreover, the missing antimatter paradox leads us to question the very nature of the universe. If the Big Bang created equal amounts of matter and antimatter, where is all that antimatter? The absence of this mysterious force raises questions about the balance of the universe. Could there be an explanation that leads us to rethink our understanding of matter itself? Dark radiation, that still unknown phenomenon that may have influenced the early evolution of the cosmos, also invites us to reflect. What other secrets does the universe hide in its vastness? Each discovery brings new questions, and each answer is just another step in our endless quest for knowledge. As scientists continue to explore the cosmos, human curiosity remains the driving force behind this pursuit. What other mysteries await revelation in the infinite darkness of space? The history of humanity is intertwined with the exploration of the universe, and each generation leaves its mark on this journey. Finally, as we contemplate the cosmos, we realize that we are part of something much larger than ourselves. Who are we in the vast scheme of the universe? The search for answers is a journey that unites us all, and although many mysteries persist, the thrill of exploration and discovery never fades. In this vast universe, every question we ask brings us a little closer to the truth, and every answer we find ignites the spark of our curiosity. So let us continue to look to the stars, for in them may lie the key to understanding not only the universe but also ourselves.